equivalent analog output voltage is most easily accomplished by the use of resistance networks. The binary ladder has been found to have definite advantages over the resistance divider. I mean to say, two types you have understood. What are those? Can anybody say? Mainly two types we have seen. What are those? One is binary weighted. Binary weighted resistive network. Other one was what? Tell. Aman. Aman, are you there? Shubham Surana. Aman. Pratham. Harsh Tripathi. Harsh Tripathi, are you there? Harsh Tripathi. And one is R12 ladder. These two kind we have understood. And what is the advantage of R12 ladder, or what is the disadvantage of binary weighted one? Who can say? Aman, Kavish Gupta. You are not listening.
Sir,
Yes.
in R2R letter we do not need high value of resistance. We can simply use
yes, only two value of resistor. Rather, one value can be used, and other one can be to make 2R. You can connect in series. So it is the advantage. And whereas binary weighted, it's so many resistors value and precision resistor getting of that various values is difficult. Anyway, the resolution of a converter is the smallest analog signal change that can be distinguished by ADC or produced by DAC due to change of digital bit. Resolution may be stated in percentage of full scale, but generally resolution of DAC is expressed as n, where n is the number of bits. The LSB, value of LSB can be defined as derived by 2 to the power n. The full scale value is defined as the difference between the analog output for the largest digital word, that is 1, 1, 1, all 1, and the analog output for the smallest digital word, that is all 0. Okay. In general, the full scale of a DAC can be expressed as full scale equals to Vref minus LSB, and LSB is given as this. So you can write this expression Vref into 1 minus 1 upon 2 to the power n. The full scale range is defined as this. The simultaneous method or parallel or flash type of ADC we have already discussed. This is the fastest one, but it is having lot many disadvantages. That is huge number of resistor and comparator required to design the converter, analog to digital converter. If number of bits are used, say 8 plus or 12, 16, like that. So that is sometimes not affordable. The counter type, basic counter type we have studied, followed by we have used some other type. So counter type is somewhat slower, but represents a much more reasonable solution for digitizing high resolution signals. The successive approximation having the medium speed. It's not too slow and too fast. And compared to the counter type. Single slope ADC you have studied, which is very simple to realize, but its accuracy is heavily dependent on RC values. And you know that value of R varies depending on the temperature. Okay, so accuracy is the problem. Then dual slope ADC you have studied in the last class. It is the slowest one. Okay. Then the previous all kinds we have studied. But its accuracy is excellent because it doesn't depend on R and C. Yes or no? We have understood all those things. So
Yes, sir.
all these things we have studied, and hence it is summarized here in this slide. Remember those, and then we are going to end this. You can now relax for this subject because we have finished in time. Now, if you have any doubt from any part of this course, then we have another 2 days, 2 lectures. We can continue there. Or if you have any kind of discussion other than this subject also, you can discuss now. I am free to accept your questions or queries to discuss. Okay, I'm closing this for now. Now it is your turn to say something. It is your turn to say something. Tell. I'll ask one by one so that nobody should be neglected. Amir Raza, you have anything to say? Amir Raja, are you there? Amir Raja? No. Ashant Takvim,
No, sir.
nothing to discuss. Then Aman, you have anything to say?
No, sir.
Okay. Any suggestion regarding this subject? Next is Akash Kumar. Akash, anything to say? Anand Dubey, Anand Dubey, Anand Dubey. No.